Hey everyone, and welcome back to the channel. Ever wonder what's happening deep beneath your feet like right now? We walk around on what feels like solid ground, but the Earth's surface, its crust, is actually a super dynamic, ever-changing puzzle. Today we're diving deep into some of the wildest geological mysteries on our planet. Crustal anomalies. It sounds like something out of a sci-fi movie, but trust me, it's 100% real and incredibly cool. So, buckle up as we explore the weird and wonderful ways our planet is constantly shifting. First off, what even is the Earth's crust? Imagine the Earth is like a giant peach. The pit is the core, the fleshy part is the mantle, and that thin, fuzzy skin on the outside? That's the crust. It's the rocky layer we live on. But this skin isn't one solid piece. It's broken up into massive slabs called tectonic plates. Think of them like giant, slow-moving rafts floating on the hotter, gooier mantle beneath. These plates are constantly jostling for position, crashing into each other, pulling apart and sliding past one another. This constant motion is what we call plate tectonics, and it's the master architect of our world, creating everything from the highest mountains to the deepest oceans. Now here's where it gets interesting. A crustal anomaly is basically a spot on the Earth's crust that's, well, weird. It doesn't behave the way our standard models predict. It could be a place where the crust is unusually thick or thin, unusually hot or cold, or moving in a way that just doesn't make sense. These are the geological head-scratchers that keep scientists up at night, and they reveal some amazing secrets about our planet's inner workings. Let's start with one of the most famous anomalies, the Hawaiian Islands. You might think of Hawaii as just a beautiful vacation spot, but geologically it's a total rebel. It sits right in the middle of the Pacific Plate, thousands of miles away from any plate boundary where you'd normally expect to find volcanoes. So, why is it a chain of massive volcanoes? The answer is a hotspot. Imagine a giant stationary blowtorch of super-hot rock, called a mantle plume, punching up from deep within the Earth's mantle. As the Pacific Plate slowly drifts over this blowtorch, the plume melts the crust from below, creating a volcano. Over millions of years, as the plate moves, the hotspot creates a series of volcanoes, one after another, like a trail of breadcrumbs. The oldest islands, like Kauai, are further away and dormant, while the Big Island, sitting right over the hotspot today, is still very much active. Hawaii is the ultimate proof that action isn't just at the edges. Next, let's travel to the other side of the world, to the Afar Triangle in East Africa. This place is a geological madhouse. It's one of the hottest and lowest places on Earth, and it's literally being torn apart. Here, three tectonic plates, the African, Somali, and Arabian plates, are all pulling away from each other. This is what's known as a triple junction, and it's an incredibly rare and active anomaly. The crust here is stretching so thin that magma is constantly oozing up to the surface, creating a landscape filled with volcanoes, deep fissures, and lava fields. Scientists believe this is the very beginning of a new ocean. In a few million years, the land could sink below sea level, and seawater will rush in, splitting the Horn of Africa from the rest of the continent. We're literally watching a new ocean being born in slow motion. How cool is that? Now let's talk about something a bit different. Cratons. These are the ancient, super-stable hearts of our continents. Think of them as the geological grandparents of the crust. They are incredibly old, billions of years old, and are much thicker and stronger than the younger crust around them. The Canadian Shield or the Siberian Platform are great examples. These areas are so stable that they haven't seen much geological action, like major earthquakes or mountain building, for a very, very long time. They act as rigid anchors that the rest of the continental plate moves around. They are an anomaly because their sheer age and stability contrast sharply with the younger, more active parts of the Earth's crust. They are like time capsules, preserving the Earth's earliest geological history. But what happens when things go missing? Let's head to the western United States, a region that has geologists scratching their heads. For a long time, scientists have been puzzled by the geology of this area, particularly the high elevation and volcanic activity far from the coast. The leading theory is that a huge chunk of an ancient oceanic plate called the Farallon Plate didn't just slide under the North American plate as it was supposed to. Instead, a large piece seems to have broken off and sunk deep into the mantle. This missing slab is a massive anomaly. Its descent into the mantle is thought to be stirring things up down there, causing uplift and triggering volcanism in places like the Yellowstone supervolcano. By using seismic waves to create a sort of CAT scan of the Earth's interior, scientists can actually see this detached slab sinking, solving a long-standing geological puzzle. And it's not just about what's thick or what's missing. Sometimes it's about what's there when it shouldn't be. Let's look at the Mediterranean Sea. The story of its formation is wild. About 6 million years ago, the connection to the Atlantic Ocean was blocked, and the entire Mediterranean Sea dried up, leaving behind a vast salty desert thousands of feet below sea level. This is known as the Messinian salinity crisis. Imagine standing at the bottom of a completely empty Mediterranean basin. Then, around 5.3 million years ago, the natural dam at the Strait of Gibraltar broke. Water from the Atlantic came pouring in through what is called the Zanclean Flood, a waterfall of biblical proportions that refilled the entire basin in possibly just a few years. This event left behind unique geological scars and massive salt deposits under the seafloor, a clear anomaly that tells a story of catastrophic change. So why does studying these anomalies even matter? Well, first, they are crucial for understanding and predicting natural hazards. By studying the hotspot under Yellowstone, we can better monitor the supervolcano for signs of a future eruption. By understanding the forces tearing Africa apart, communities there can better prepare for earthquakes and volcanic activity. These geological quirks are the planet's warning signs and pressure release valves. Second, these anomalies are treasure troves of natural resources. The intense heat and pressure associated with many anomalies are perfect for forming valuable minerals and gems. For example, many of the world's diamond deposits are found in the ancient stable cratons. The heat from hotspots can also be harnessed for geothermal energy, providing a clean, renewable power source. Finally, and perhaps most importantly, these anomalies are fundamental to understanding the story of our planet. They are the exceptions that prove and refine the rules of plate tectonics. Each anomaly we study adds a new, exciting chapter to the biography of Earth. They show us that our planet is not a static rock, but a living, breathing, and constantly evolving world. The ground beneath us is a stage for a drama that has been unfolding for billions of years, and we are just beginning to understand the plot. From a volcanic paradise in the middle of the ocean to a continent slowly ripping itself in two, Earth's crustal anomalies are windows into the powerful forces that shape our world. They remind us that we live on a dynamic planet that is full of surprises. So the next time you feel the ground, remember the incredible journey it's on. Thanks so much for joining me on this geological adventure. If you found this as fascinating as I do, don't forget to hit that like button, subscribe for more deep dives into our amazing world, and ring that notification bell so you never miss an update. Got any questions or ideas for another topic? Drop them in the comments below. Until next time, stay curious.